Welcome, the physics mindset followers. Thank you for coming. This time round, we are here to dig deep into our physics, our technical, our engineering, as we said at the beginning. This channel, the physics mindset, is based on bringing information on electrical, electronics, and solar engineering. As we said at the first episode, that we shall be able to give you a multiple knowledge, multiple practical lessons, multiple theory. But before we dig much into the theory, the practical, the engineering part, we want to see how electricity started. How did these guys came up to call current? How do they came up that there must be a voltage? You remember at the beginning, there was candles before the technology takes over. Those ancients, our grandees, they used candles as a source of light. Not this. They used candles as a source of light. They used walking. They used to walk, and the use of these horses as the only source of transport before technology hits. Okay? Now I want to see these guys, the founders, the true physicians, the scientists who came and think, the philosophers who came and think much about the change of the world or the revolution into electrical. All technology you're seeing now is derived from the foundation of the electricals, where we are going to dig our foundation also to the people who are starting to know where electricity came from, where electronics came from, where solar engineering came from. We want to talk about this guy. We shall talk about one by one as we go through our series of education in electrical, electronics, and solar. But it is very good and it inspires. For me, it inspires me to talk about these guys, the first founders. As you can see, the founders, the fundamentals of electricity. Those are the founders, the way electricity came up to be electricity. Some of us were born when electricity is already surpassed everywhere. Now I want to talk about this guy. Let's talk about one guy first, before we go more on others. We just, as I told you, we shall move slowly and calm. You know, this inspiration of these physicists, it inspires someone that, oh, where we came from candles. Now we are on lights, tubes, telephones, computers, you know. But by then, they used to write, and the only way of communication was writing on a paper with the ink. But right now, we're using computers and it goes online. Before, it was writing, and the only transport to take a message was through walking and use of the donkeys. I mean the horses. And people with horses were the noble peoples, the rich guys. If you're not rich, you will use your foot shubish. Like that's walking. And that was the only transport means. And night comes, day comes. But when night comes, they used candles and gas as the source of light. But right now we have wind turbines, water turbines, solar system, and this is our aim, to explore all the foundation and the way to use this electrical, electronics, and solar, as you know, as you want to know. Okay? Now let's look at this guy. His name is Andre Marie Ampere. Andre Marie Ampere, he was a French mathematician and a physician. A French true mathematician and a physician. You know, during those days, these subjects, they combine. If you are dealing with physics, still mathematics is interviewing inside there. If you are doing in mathematics, physics will come inside there, chemistry. Okay? Now let's look at this guy. Who was this guy? He was from a humble family, Andre Marie Ampere. As you can see, or the sound of Ampere. We are going there. It was a name. He was a French mathematician and a physicist. Check this. People who are living in Lyon. Lyon, which is in south of Sudan, south of France. They had a humble physician. Who was there? He was a brilliant physician, brilliant kid, knowledgeable. He used to read for more hours a day, calculating, doing a lot of mathematics. But by then, mathematics was written in a Latin language. People who are mathematicians, you can check in your books, textbooks, the Asian textbooks, the Abbott. You will find that mathematics is written in Latin way. Now this guy, Andre Marie Ampere, who was born in 1775. He was born on 20th January 1775 in Lyon. Lyon is found in France, south of France. Lyon, yeah, I know my friends there. I will have to come and have a brief pictures or a video on this guy, the Ampere, Marie Ampere, or his grave, if I find it. But now, he died in Marseille. But before Richard his death, let's look at this guy. This guy was so humble that he was eager to learn mathematics and physics. Those are the basic things he wanted in his life. You know, it may be a blessing, but a blessing with hard work, you achieve the success. He used to calculate things. Even his parents used to call him to do some work at home. But he insists sometime, and the parents, after some time, they said, let's leave this boy. This boy was doing a genuine research. Andrew, who is called like Andre Marie Ampere, after a lot of times, in 1820s, he came up with an experiment. Which experiment? He came up with an experiment of, he defined electric current. He defined the electric current. You know, in electricity, that is a cable, a wire. When electricity passes through, there is an electric current flow. Okay? Electric current, these are electrons flowing through a cable or a wire. Okay? Now, this guy, Andre Marie Ampere, defined it that in a cable, there is current passing through. You see? There is a flow of current passing through a cable. That's the definition of a current. Okay? And these electrons are either positive or negative. We go slow, we don't need to rush. We shall all look at this when we come up into our formulas or workouts. Flow of current in a cable is defined as an electric current. Okay? These currents are electrons, and these electrons are either positive or negative. Okay? We move together at par. Let's move together. We don't need to rush. We are coming, we're looking at our physicist man, a mathematician and a true physicist from France, who was born in Lyon. But unfortunately, he died in Marseille. in Marseille. So his grave is in Marseille. One day, one time, we're going to see his grave as those are the founders of electricity. As our topic says, fundamentals of electricity, or the founders of electricity. Now we have one. We have seen now one person. Who is who? Andre Marie Ampere. Okay? Check this name. I know this name, technicians. Ampere, you have seen, you have heard it somewhere on all electronic gadgets, which is amps. Some people call it amps because this guy, he defined the unit of electric current to be the ampere, which was named after him because of his research and workouts they completed, and said since Andre Marie Ampere has done a lot of research on electric current flow of electrons, both positive and negative electrons, let us give this unit after his name, which is amperes, where today's world we call it amps. That how many current? There is 22 amps, there is 1 amps, there is 10 amps. These words I've heard it a lot of in the field of electronics, electrical, and solar. And we are going to look at this forever and ever. It will never change, as his unit, the unit of the current, is called the SI unit. SI unit is the standard unit which all the world will use. It is the standard which is measured by the IEEE Institute. That is the Institute of Electrical Engineering and Electronics. We shall again look at how those IEEE combined electrical and electronics. How do they combine to become a one university, and they form a one university which teaches both electricians or electrical engineers and both electrical engineers and electronic engineers. Before they started finding solar came before. Solar came after these electricals. Electrical was the first thing to be found. Then electronics came. Then solar came last. Okay? After electronics came in, then solar engineering came last. As we shall be switching on electronics, switching on solar, switching on electricals. Now this guy, he didn't stop there. At his experiments, he experimented an effect of electric current and electromagnetic field. Let's check on this. An effect of electric current with an effect of electromagnetic fields. Okay? Let me explain this very well so that you capture the meaning. There is an effect of electric current when I need a cable. Okay, we shall do some experiment later. When there is a cable, let's use here. When there is a cable like this, okay, this is our cable, a wire. Current will pass through this cable, okay? And there is an effect in this cable. This cable with either effect of current will either be heat will come in, small heat. Another thing, when current pass through a cable, there are some electromagnetic fields. These are fields, like a magnet. What's it? Let's see a magnet. A magnet has a magnet has magnetic fields. Okay, like if this is our magnet, this is positive, negative. Positive will give out its magnetic fields. Okay, they'll point out. Okay, now a negative side will bring inside. Okay, and we shall be having, if this is our magnet, we shall have a negative pole and a positive pole. Positive gives out, negative push in. Now, these are the fields I'm talking about. The magnetic fields. They are either positive or negative. Okay? Either positive or negative. It implies the same thing with the cable or a wire. When current passes through that wire, the effect we are talking about, this effect which we are talking about, the effect of electric current and electromagnetic fields, these are the effects. When current passes through a cable, there will be electric magnetic fields. This one here. When current passes through a cable, there will be an electric magnetic field. Also, which means electricity also create magnetic fields, both positive and negative, as we shall see as we go on, their effect. Now, for example, the electromagnetic field. Before electromagnetic field, the first word they used, this man who was the founder of this electrodynamics, okay, which nowadays we term to as electromagnetism. This man, Andre Marie Ampere, he didn't sleep. He had so small sleep, as the books say. He used to do research day, afternoon, and at night. He sleeps for small hours. This man, after he found out that he was the founder of electrodynamics, that this is one of the physics topic which is too interesting in the foundation of electricity. As I told you, we are looking at this man as the founders of the fundamentals of electricity, one of the founders of electricity. I never wanted to go into, we start from voltage, resistance, current, we start calculations. I wanted to first go through, we look at these guys, what they did. Can it inspire us to go through this journey of electrical or electronics or solar? What inspired them to? How do they come up to bring up this knowledge so that today's life, we can't live without their knowledge? We can't live without this man's principles, the Andre Marie Ampere. We cannot. If electricity goes at home, automatically you remember the use of this man, Andre Marie Ampere. His use is too precious into our life. What can we add on his journey? Because if you sit very well, sit down and think, if you can think like him in one day, no. It can't happen in one day. It took days, it took months, it took years to bring up this electrodynamic, which today we know as, we call it electromagnetism. Some people may not know electromagnetism is. Let me give you an examples of electromagnetism, okay? Electromagnetism, let me give you a daily use of electromagnetism. By then they used to Andre Marie Ampere called it electrodynamic. Okay, most physics books, they teach it as electrodynamics, but today we can call it electromagnetism. As I've shown you here, the sample of a cable where current is passing through. When you switch on, and current will pass through a wire. But that wire there is an effect which will be created on that wire. This effect is electromagnetic field. These ones, they will be around the cable, but you can't see them with our naked eyes. Okay, we cannot see them. And these are one of the examples you can know that there is electromagnetic field. Have you seen a cable with high voltage? A cable with high voltage, when it taps your hand, it can stick on you. That's an electric shock, and sticks on you like a magnet, until someone will bring a stick or a wooden or a non-conducting material to separate you with the electric cable. Do you know where that energy comes from to stick on you like this? This cable will come and tick on you with no help, or there is no one holding it, but it will be like a magnet on your body. That's what I'm talking about, the electromagnetic field. It has that power of attraction, that magnetism attraction. And this is the one I'm talking about, the fields. When you switch off, that cable will just drop itself without anyone touching it. When you switch on, it can start moving like this. That is the power of electromagnetic fields. They are getting attraction and repulsion, which is the law or the principle of magnetism. Like poles repel, unlike poles attract, as we shall see as we go on slowly. Now, where were we? I was giving you an example of this electromagnetic or electromagnetism. The founder, this guy, Andre Marie Ampere, who is the founder of electromagnetics, which we call at this day today, we call them electromagnetism. But some physics will call them electromagnetics. But another physics books will call it electromagnetism, which is the starting of current, the beginning of electricity. Before the voltage came in, we first had current. Before voltage came in, they first found out that current is in existence. Okay? And this is where we are going. After this topic, we shall look at and where did the volt or the word voltage came in. I said we move slowly. Let's enjoy this topic. Each topic has a credit in it, has some understanding, some foundation. We dig from down, as I told you. Though I'll explain a bit of it, but in a practical way. When you listen, you can pick something. When you listen again, you pick something again. That's the logic behind the science of neurosurgeon or neuro, behind our understanding. When you watch a video today, you understand. Again, when you watch, you understand more. Again, when you watch, you really understand more and more. As we said, electrodynamics, which are electromagnetism. Now, these are our day-to-day things we are living, we are using. One of them is electric motor. Electric motor. Okay? Some people don't know electric motor. Electric motor, let me give you an example of a washing machine, which is in our houses, a blender, which we use in our houses. Those are electric motors. They use electric motors. There is a air dryer for the women. They use electric motor. Now, the definition I can give you on this electric motor is it changes electricity or electric energy into mechanical energy. That is a motor or electric motor, which it uses a principle of this guy, the principle of electromagnetism. These motors, all the fan you have in the house, the microwave, the washing machine, the blenders, they all use the principle of electromagnetism. And those are electric motors. They have a motor inside them. Now let me give you an example, small explanation about these motors. Let us look at which one? Washing machine, a blender, or okay, let's look at the blender or a washing machine in our houses. Do you know how it turns like this? Our clothes inside. Okay? When you close, this closing is like a switch that it's ready for current to pass through. Then the current, there is a switch you press to turn on the current so that it passes through. When you open, the circuit is broken. We shall look at this. Now I'm giving you an example of this man's principle, Andre Marie Ampere, his principle of electrodynamics or magnetism, giving an example of electric motors. Let's look at the washing machine. Washing machine as our example. Let me explain it so that you can know the principle of electromagnetism. We are coming to electrical. The moment you miss, you will miss a lot. Now, this washing machine, the principle. Let's come here a bit. The principle of electrodynamics. The washing machine, as I said, don't forget these names. Electromagnetism. Okay? Don't forget electromagnetism. Those are something like two words in one word. There is electro and there is magnet. Okay? There is electro and magnetism. Where does this principle apply? It means electrical, then there is a magnet. Okay? I want you to see it in your mind. There is electrical and a magnet. Then if you combine these two, they become electromagnetism. Okay? It means there will be a cable with electricity. It is a short form of electricity. Then they call it electro. Okay? There is a cable which has electricity. Now this cable they are going to wind. Okay? They are going to wind. They will get something, a metallic thing, and they wind this cable. Yes? Yes, a metallic thing, and they wind. Oh, let me give you this, the simplest example. You'll get this is our magnet, okay? Take this to be our magnet in your mind, though it is a marker, but you take it, this is a science explanation, that science experimental. You are seeing it in theory, but you can see it in practical in your mind. This is our magnet, okay? Take this to be our magnet. Then get a cable, wind this cable, a naked cable, which is a copper wire. You call it a copper wire. Wind it like this. Remember, it has a starting. For example, this is our magnet with a positive pole and a negative pole, okay? Get your copper wire. This is our copper wire. It starts from here. Then wind. Then this is the ending, okay? I don't know if you're seeing it very well. Remember, we have our magnet. This is our bar magnet. This is our magnet. And this is our cable. Our cable. With, now, apply. Remember, this magnet here, as we said at the beginning, that our magnet has magnetic fields around it, which you can't see. If you want to prove, you just extend it near the metal, you will see the attraction or the repulsion, okay? Now we can't see. Wind your copper wire around this magnet, okay? You round it. This is the beginning, this is the last point, okay? Now, we get electricity. We get electricity and apply here on this beginning, okay? We begin our current. Current start passing, and current will come also here, going out, okay? Current will come. Current will reach here when there is magnetic fields on this bar. And also remember, we have electromagnetic fields on the cable, which is having current, okay? Now they find themselves here. What happened? The principle of magnetism, like poles repel, unlike poles attract. We don't know that this point will be a negative, or this point will be a positive with the magnetic fields. Our cable is going to be having electromagnetics around it, okay? Around it, it will be having electromagnetics around it like this, okay? Like this. Now they find themselves. Let's check here. The magnet is having its magnetic fields. Now also the cable has brought the cable also, which is coming, is also having magnetic fields around it. Now magnetic fields, check this small, excuse me, we shall be having a collision of the magnetic fields Already the magnet has fields around it. Even the cable is coming with electromagnetic fields. These fields will end up making this magnet move. Okay? They will end up making this magnet move like this. Clockwise and clockwise, clockwise and clockwise, clockwise and clockwise. And this principle, when you apply another magnet like that, when you apply another magnet, positive, negative, with our turns, and a current, okay? Here, the magnetic fields will be like this, changing, positive, repelling, attracting, repelling, repelling, attracting, repelling, attracting, okay? Because they have collided here. And we get another bar, the same thing as we have done like this. This is our beginning. We control, we turn, we wind, negative, positive. This is a bar. Also the same thing. The magnetic fields will be like this. I'm giving you the principle of a washing machine. Now, this is our motor. It has the beginning, A. Also here we have A. This is B. This is the end. This is the beginning. This is A, B. Now, there will be a space in the middle of these poles, okay? And this metallic thing, which you'll be having where you put your clothes, okay? If this is the door, you put here your clothes. The door, now the motor will be inside. It is the one which will be doing like this. It goes likewise, then it turns like this, then it comes like this, because of the principle of magnet and electric. And this comes to be an electromagnetic or electromagnetism or electrodynamics. And that's how the principle of a washing machine washes our clothes. Yes? This clothes, this motor inside will start moving. For it, it is in the middle. It doesn't touch anything. The thing which you put your clothes inside the washing machine, it doesn't connect anywhere. It doesn't connect anywhere in this. There is a permanent magnet, and this is our motor. And these connections are brought together and they connect to life. There is, this one will become our neutral. And this neutral also will be connected to this one. And we have live and neutral. And the principle remains the same thing like this. When this magnet bar has magnetic fields which are complaining, and also another magnetic bar also behind it, there are very many. We shall look at in the motor. I'm going to show you a motor. After, you'll see a motor, how the windings are winded in one bar. Then and they wind another windings in another bar. They wind another windings in another bar, but in a circle. They press them. I'm going to show you. You'll see the image of the motor, and you will see windings, a lot of windings on the magnetic bars. And when you switch on current, the cables will be in a coil way, and they will complain. Their electromagnetic fields will start complaining with the permanent magnet which is there. And this permanent magnet will start forcing this washing thing, which is this motor inside here, which is not connected anywhere. Only the force of these electromagnetic forces and the magnetic and the permanent magnetic fields They are the one to drive this. No connection. I'm going to show you next. You will see the motor. And this is the motor which I was talking about. And this is the principle of this man, Andre Marie Ampere. That was an example of a washing machine. Though we have very many principles where his experiment, where his science, his fundamentals were applied in our day-to-day life, like the speakers, Also the same principle. He was the founder of how these speakers you hear, the speaker in your phone, the speaker in your TVs, the speaker in your radios, the speakers, the microphone, all is the Andre Marie Ampere principle, which led to the foundation of those things, electrodynamics or electromagnetism. They use the principle, these speakers. Check this. You see these headphones? Okay, these are headphones. Then this, this is a speaker. I will show you the speaker, and I show the diagram. And all comes out with this principle, electrodynamics or electromagnetism. Even the speaker. Let me explain a brief explanation about the speakers. Okay? Also the speaker, let's say this is our diaphragm. On this diaphragm, we are going to get our copper wire. Our copper wire, we wind it on this paper. Okay? You do a winding on this paper. After finishing winding, we get a permanent magnet, which is round. If you open the magnet, the speaker you will see, which is round like this. Round like this. Then we shall bring our cable, our cable, which is winded here on the book, on the paper, or a diaphragm. Press it in the middle. In the middle. Do not touch anywhere. Let it be in the middle, in space. And this is the principle of a speaker, okay, or a microphone. This diaphragm, this coiled cable is pressed in the middle like this. No touching anywhere. This is, as I said, our practical theory. Let's take this to be our magnet. It is round. Okay? I will show you the diagram. Then press this. Do not touch anywhere. Let it be in the middle. It dances like in the middle. Because if it touches the walls of a magnet, that's when you hear some hum from the speaker. When a speaker falls down, this diaphragm, this cable which is winded here, the small cables, they will touch the magnet, and when you switch on your speaker, these electromagnetic fields will be colliding much with or knocking with the magnet, and you will hear the sound coming, a hum in the speaker. There it will demand you to take to the technician to change the diaphragm so that it comes back, or to bring it back in the middle. And that's the principle of this man, Andre Marie Ampere, who brought and founded the electrodynamics, and he defined the electric current and how it is measured. Okay? He didn't stop there. He invented the magnet. This man invented the electromagnet. Yes. If another example, if you do like this on, if you get your pen and you scrub on your body, this pen will be charged electrostatic. Okay, these electrostatics will create a magnet. Those are electrostatics, the magnets, and it can attract a paper. I think you have done some of that experiment. Okay, and it didn't stop there. After inventing the electromagnet, he then invented the ammeter. This guy, ammeter. I know the beginners, the advanced students, the technicians already in the field, and engineer, they use ammeter. Ammeter is used to measure current. Ammeter is used to measure current. Which current? Its SI unit is in amperes. And who was Ampere? Is Andre Marie Ampere. And the unit of the current was named to be amps or ampere after the discovery which Andre Marie Ampere made, just to honor his name, that he has done a lot of work, a lot of research to do all what is making the technology of today. Not to forget him, they decided the SI unit, or the standard unit for current, to be ampere. And up to date, this man's name will always be on our mind and on our lips. We shall always read him, we shall always use his value as a SI unit of current. Wherever you see current, it is measured in amps. Whenever you see current, just know this guy made a very big fundamental in electrical. Without current, power is not there. Without current, there is no electricity. Current only appears when there is electricity. Okay? And since then, this guy was honored, and that's why our current is measured in amps. Forever, no more, no change. No one will change unless you make some invention more than his invention, which he did. Andrew, I honor him. Andre Marie Ampere, respect. Wherever he is, rest in peace. But he did the foundation of electricity. Without him, we wouldn't have been having all these lights, all these phones, all the electrical things, because he was the founder of current and the founder of electrodynamics, which nowadays you know as electromagnetism, which you use in your houses as the speakers, the microphone, the microwave, the microwave, the washing machine, the dryers, the hair dryers, a lot of things, the blenders, all this because of this man, Andre Marie Ampere, because of his hard work and his research in his physics, experimentals in physics. He was given a honor to open up a world of technology. Without his hard work, we wouldn't have been here with all this technology. We would have been on candles. You never know. Because he removed us from being on candles into starting the electricity. Now on our next episode, we are going to look at, if current was found, where was the voltage? We're going to look at the voltage, now we have found that current is available. We need to know, where did voltage came from? Our next episode, we need to look, where did voltage come? Since we know now the current, and it was brought by Andre Marie Ampere, a French mathematician and a physicist who was born in Lyon and died in Marseille with his great work. He died at 60 years. He was so brilliant. Who learned a Latin language at the age of 11 years. Can you imagine that? At the age of 11 years, because you want to master mathematics. Because mathematics works were done in Latin language. Okay? This guy, at the age of 11, he said, now, without me studying Latin language, I will not master these mathematical solutions. Then he went and studied and mastered Latin because of his interest in mathematics and physics. And that's why he was able to come up with what we have today. The electromagnetism. Everything is electromagnetism. If you look at what you use in your kitchen, in your bath, on yourself, on your phones, there is a microphone, there is a microphone and an earpiece. Without his principle, you wouldn't have had the things on the phone. He did a lot of changes in the modern world of technology. And I agree him and I appreciate, honor him, Mr. Andre Marie Ampere. Rest in peace. Check the next episode, which we are going to deal. If we find out, we are going to deal on voltage. Where did we came up with the word voltage? How did we came up? How do electricity deal with only voltage? You look this side, look this side. Once you enter into electricity, just know you're going to talk about voltage only, all the time, and current and resistance, but mostly voltage and current. Good enough, we have discovered who discovered current, who brought current to be in existence. It was Andre Marie Ampere, a French mathematician and a physicist. Now we are going to look at the next episode. We are going to look at where did voltage came from. Was it again Andre Marie Ampere? No. For him, he did his job of current and he relaxed. He was, of course, he was still doing his experiment. As you know, world goes on and world, the generation change. Okay? Now, after that current, who again came up to bring us what we call voltage? Next episode, don't miss. It will be so interesting. If you master, before we start our workout in electrical, master these words, because we are going to use voltage, current only in the whole course of electrical. Find voltage. This voltage is low. This power can't work. This bulb can't work without a voltage. There is small current. It is very good to know where the fundamentals came from. This is Dennis, your man, your physics mentor on Physics Mindset. Don't forget to subscribe. Don't forget to like. Comment if you want to know something. Comment. I'll reply you. Thank you for watching. See you in the next episode.